Find the equation of a line. Okay, I'm going to hit pause, and you guys are going to go. Hope I'm going to pause. Okay, that's time for me to pick on you. I'm going to just say m equals y2 minus y1 over x2 minus x1. Change in y over change of x is your slope. Okay, let's try to sub in, please.
So you do negative 14 minus 2.
Yeah.
Over 3.
Yeah. I call it 3 minus negative 5, but it's the same thing. Okay, now just a reminder for you guys here, the x's got to line up as a point, you know, the first point, second point, all line up there. Melody, do some addition, please, for me.
Negative 16 over 8, which is like...
Which is totally like negative 2. That's good. Wonderful. Shannon, do you remember how to make an equation to deal with the slope and the point?
Yes, you would go back to your y equals mx plus b.
You certainly would.
And you would sum in the points from above, I believe, or you would just use one of your equations.
You can pick your favorite point. What is your favorite point? Negative 5 and 2 or 3 and negative 14?
I like your negative 14. Yeah.
There's your explanation. Okay, go ahead.
It would be negative 14.
Yeah.
B equals to negative 2.
Yeah.
Times 3
Yes.
plus b.
Good. And then it's going to solve for b, so negative 14 equals negative 6 plus b. What is that? Negative 8 equals b. Y equals negative 2x negative 8. Okay. Here we go. Average rate of change. Okay, we're going to get into this a little bit tomorrow. I'm just going to do the basic advanced functions calculations to make sure you can do this. This was a pain in advanced functions. I hope when I sat through Mr. Lacey's, with Mr. Lacey's class last semester, it was the last, he did the same thing at the end of every chapter, which is what every teacher does. They do the whole thing in the last part is, let's find the average rate of change of this type of function. Right? Let's find the instantaneous rate of change of this type of function. What calculus is the instantaneous rate of change found instantaneously. Okay, right? So instead of being found, like, remember you do like f of 9.8 minus f of 9.0001 and all that sort of stuff. Yeah. That was difficult and painful and tedious. Okay, so calculus will make it go quicker. I'm going to review for the final time ever in your lives. Today I'm going to go through this again to make sure you can do it because the same concepts apply. Average rate of change is just between the slope between 2 points. That's all it is. Okay, so if I say to you, for example, I don't even know, 5 we'll call it. I don't know. Example 5. If f of x equals 2x squared negative 5x plus 1, A, find the average rate of change from x equals 1 to x equals 3. Who are we up to? John. Huh? Do you recall from last semester how you find the average rate of change? No. Okay. That was my one weakness. That's okay. Patrick, do you remember how you find the average rate of change? Yeah. Go ahead.
You just sum the numbers and convert.
Yeah. So basically for this one, it's going to be, it's going to equal f of 3 minus f of 1 all over 3 minus 1. Right? So it's going to be the values, the different values divided by the time that. Okay? This is slowly coming back. Courtney, you're remembering this? I hope. Nick, this is good.
Is there any reason why you did f of 3, you subtract f of 1?
No, I did not. I could have used the other one. Okay, backwards, just just the signs would flip for both the numerator and the denominator. All right, f of 3, this is where I hope that Reed has a beautiful calculator that can do this in one step, okay? Because I'm not going to waste, you guys don't calculate f of 3. Do you need me to show you how to do f of 3? I hope you don't. You guys can got this? 3 is just sub 3 in for x, okay? So Reed, can your calculator give me f of 3, please? Actually, I can do it in my head. 9 times 2 is 18, minus 15 is 3, plus 1 is 4. Minus 1 is negative 2. Is that what your calculator says? Oh. Somebody confirm? Matt, we're good?
Need that brackets.
Okay, Matt confirms, and it's confirmed then, okay? That turns to 6 over 2, so this equals 3. I can't remember how they did that. What was the, so I don't teach advanced geometry. What do you call the left-hand side of that? What? No, right, but that's all they call it. They didn't give it like a special or anything else. So the rest of that for something else. Okay, that is the average rate of change. Okay, so that's like Mr. Sadler was driving down the road. At this time, he was going this fast. At this time, he was going that fast. What was his average speed? That'll be that one. We'll get to pictures and all that stuff, and we'll really get to the calculus. This is just data. Letter B says, find the instantaneous rate of change. And you guys are going to actually slog through this one. So what I want from you is I want f of 2.1 minus f of 2 all over 2.1 minus 2. Then I want f of 2.01 minus f of 2 all over 2.01 minus 2. Then I want f of 2.001 minus f of 2 minus 2.001 minus 2.
Aren't you supposed to do?
Either side of the two? They're supposed to? I don't know. I don't teach advanced geometry. I don't know.
Oh, okay. That'll be slightly to the left.
So you guys want me to also do f of 1.99?
No, not also. Instead of.
Instead of your 2, just make 1.9 and like.
Oh, really? All right. Yeah. Really?
Yeah.
Yeah. I wonder I don't teach advanced functions. I would cringe every time I did this problem.
Why?
Why? Because I'm going to show you maybe
Okay.
Monday or Tuesday.
Is that when we get to live?
Not quite yet. What are we really actually trying to do here? Just let's do the calculus part before I actually goes. What are we actually trying to find? Because we're finding what? Like, what do we really want to do? Yes.
Basically, you're making it so your x is almost 0, like the difference between.
Right, and that's exactly what we want. We actually want 2 be 0. That's what we want. We can't get 0 because you need to have 0 over 0, right? But you want to have, that's what calculus does. It makes it so that the difference is nothing. Calculus is really, really big numbers and really, really small numbers, right? So that'd be the 0. This, as a student and as a teacher, is making me a little bit nauseous right now. Okay, and hopefully you felt this way last semester too. Hopefully as you were doing these questions last semester, you said, there's got to be a better way.
I did these questions twice. One where we did an example of it, and when I did it on my final exam.
Good.
I never actually did an entire.
Good. Well, you'll never have to again after today, but I just want to get this into your head. So when you say to me, Mr. Sadler, why are we doing this? I'll say, remember on day 2, how painful it was? I don't want it to be painful like that anymore, so that's what I'm moving forward. Right? Because this is, I'm sorry, I shouldn't say this, right? But this is, yeah. Right? Like, you guys remember this last semester. It wasn't fun, Matt, was it? I do it. You didn't mind it. Okay. There's so many ways to go wrong. This is where I'm going to rely on Reed's calculator here. I trust you guys to do this yourselves. I'm going to rely on Reed's calculator to give me the answer here because I can't do this in my head.
4.
Sorry? 5 over 4?
Works.
Is that what works out to?
I don't know. I did the function. I used Wolfram Alpha.
Don't use Wolfram Alpha. You cannot use Wolfram Alpha in this class. I want you to think. I know it does, but I don't. The problem is, I don't want your brain. I want you to think through these examples. For this, it's okay. It's a calculation thing. right? But in general, like, I want you to think through
Oh,
things.
it's just double check. I don't even know.
Did anyone actually work this out? Can somebody please? Because this is awful. I can do the denominators for you.
Thanks.
Oh.
Zero
0.6 or 0.2? Somebody confirm that?
I got the stat.
Oh, there's 3. Yeah, you got her too. Is the slope going to be 3 all the way? I hope so. That'd be wicked. Including the slope right now. I'm going to stop that for the video. I don't think you guys need to hear me complain about this function.